So what we're going to look at today is rates on a graph. Instead of just finding the unit rate like we did yesterday, we're going to make a graph out of it and be able to compare them. Decide which is better, which is faster, which is the better deal, those types of things. So the first example, we have a cheetah and a gazelle are running at constant speeds. What does it mean if you're running at a constant speed? Steady, right? Means you never get faster, you never get slower. Is that really possible? Like, in real life, can we run at a constant speed forever? No, I don't think so. Okay, I try really hard on my treadmill, right? On your treadmill, if you set the speed, it stays at speed. But what happens if you get tired and you don't stay at that speed? You fall off, okay? If you've ever fallen off a treadmill, it hurts, it's bad. And it gives you major, major road rash. I'm not speaking from personal experience or anything, okay? But it's not a good situation. So we're gonna pretend hypothetically that these animals are running at a constant speed. But is it possible to probably run at a constant speed for a short amount of time? I think so. I think for a short amount of time, I could continue running at one speed. I mean, even for a half hour, I could probably run at one speed, okay? Once it gets longer than that, I'm probably gonna either slow down or maybe walk, right, because you get tired. So we're gonna assume for a short amount of time, the cheetah and gazelle are running at a constant speed. And if you look at the table, it's only going for 7 seconds. Is it possible to run at a constant speed for 7 seconds? I think so. I think all of us could probably do that for 7 seconds. I'm not asking you to run at your fastest speed, not your slowest, just a constant steady pace, okay? So the cheetah at time 0 has gone 0 feet. That makes sense. If time hasn't started, you haven't moved yet, okay? After 1 second, has gone 102.6 feet, okay? Now they keep running and they're running at a constant speed. So how far would have the cheetah gone in 2 seconds? Brayden. 200, so fill this in, and 5.2. And every second after that, how much further is the cheetah going to go? What are we going to keep adding on? Brayden. Yeah, because they're running at a constant speed. So for every second they run another 102.6 feet. So we have to do 205.2 plus 102.6. So we should have 307.8 plus another 102.6 for 10.4 plus 102.6, 513 plus 102.6, 615.6 plus 102.6, 718.2. So after 7 seconds, the cheetah has run 718.2 feet. Okay. Then we also have the gazelle. A gazelle can run 73 feet in 1 second. So at 1 second, the gazelle is at 73 feet. Fill that in. What would it be at 2 seconds? Addie. 146. Okay, at 3 seconds then, what are we going to add on every time? What should I keep adding on? Isaac. Yep, keep adding 73. So 146 plus 73 is 219. Another 73 is 292. Plus 73 is 365. 438. And 511. Okay, so far so good? Okay, that wasn't that hard. Filled in the table. Now we're going to graph it. We're going to graph both of these on the same graph. Okay, so let's start with the cheetah. I'm going to do it in green just like it's started here. Okay, so we have 0, 0, 1, 102.6, so that dot's just a little bit above the 100. Okay, now we're going to try to be as accurate as possible. Okay, it's not going to be perfect, right? But we're going to try to be as accurate as possible. So 2 seconds, 205.2, I don't know, just above the 200. Put a dot there. 3 seconds, so time 3 seconds, go up to 307.8. Put a dot there. 4 seconds is 410.4. About right there. 5 seconds is 513. 6 seconds is 615. And 7 seconds is 718.2. And then connect the dots. Is our line pretty straight? Should it be straight? Why should it be a straight line? It's running at the same speed the whole time. We kind of talked about that yesterday, that we could pick any point on that line and it would tell us the speed. Okay, so I'm going to label this to make sure we know this is the cheetah. Okay, now we're going to graph the gazelle. So the gazelle starts at 0, 0. Starts at the same spot. Okay, then we have 1 second, 73 feet. So kind of about right where that arrow is. 2 seconds, 146. Just below the 150 mark. 3 seconds, 219. 4 seconds, 292, so almost 300. 5 seconds, 365, so just above 350. 6 seconds, 438, kind of right on the cheetah's ear. And 7 seconds, 511. And connect the dots. And that's the gazelle. Is our line going to be perfect on these? Probably not, right? Due to human error. That's probably our problem, that the line is, if your line doesn't end up perfectly straight, it's probably because we didn't graph everything perfect, okay? Due to human error. Is it close to straight? Yeah. And if we had a computer graphing this, would it be perfectly straight? Absolutely, okay? Because both animals were running at a constant speed. So which graph is steeper? The cheetah. So let's fill that in. The cheetah has a steeper line. The speed of which animal is greater? So which animal is faster? Abby. The cheetah. We can tell from the graph that the cheetah's faster because the line is steeper, right? Just like if you're going skiing, you go down the black diamonds, you go faster, you stay on the bunny hill, you go slower. You don't want to get hurt, you stay on the bunny hill, okay? So the steepness determines your speed. The steeper it is, the faster it is, okay? Now we're gonna look at another problem that this time we have the Boulder bike tour operators decided to rent bicycles for their customers rather than having customers bring their own bikes, okay? So, you know, sometimes you go to a big city and they have like, you can rent a bike and go on a tour of the city, right? Okay? So they must have used to have had people bringing their own bikes. Well, that's a problem because their bikes wreck and they don't work or whatever. So they're gonna rent bikes instead, okay? But they have to figure out how much they're gonna charge. So they called 2 bike shops and asked for estimates of rental fees. We have Rocky Cycle Center. This is their weekly rental fees. If you want to rent 5 bikes for the week, it's going to cost $400, 10, $535, and so on, all the way up to 50 bikes will cost $1,200 to rent them for the week. And we have Pebbles Bike Shop. 5 bikes are going to cost $150, all the way up to 50 bikes cost $1,500. Okay, we're going to graph this. We need to figure out what goes on the x-axis and what goes on the y. Now remember, yesterday we said the x-axis is always our independent variable. The y-axis is always our dependent variable. So when I look at these tables, what's our independent and what's our dependent? What's independent, what's dependent, Adam? Bikes are independent. So our x-axis is the number of bikes. And our y-axis is going to be the rental fee. Okay, I'm going to not show the tables right now. We all have the tables on our notes, right? So we can graph these. Okay, we have number of bikes down here. That's our independent variable. Rental fee is over here. That's our dependent variable. Because how much we pay depends on how many bikes we rent. Okay, now we have to number the graph. Nothing is numbered yet. So when I look at, if I scroll back up to the tables, how would you number the graph for number of bikes? What would you count by? Casey? 5s. That seems to make sense. So along the bottom, let's go 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, all the way up to 55. Okay, go ahead and label that. Okay, then we have to label the other direction, the y-axis. Looking at the tables, what would it make sense to count by on the y-axis? Lexi? Hundreds would probably make sense. Okay, so let's count by hundreds. We have 0, 100, 200, 300, 400, 500. And keep going all the way to the top. Okay, once we have the graph labeled, now we can go ahead and graph our points. Okay, so we're going to graph everything for Rocky Cycle Center first. So look at that first table. It says for 5 bikes, it's going to cost $400. 5 up to 400. Put a dot there. 10 bikes cost $535. We have to estimate a little bit, but about right there. 15 bikes is $655. About halfway is between 600 and 700. 20 bikes is $770, getting closer to the 800 mark. 25 bikes, $875. 30 bikes, $975. 35, $1,070. 40 is $1,140. 45, $1,180. And then 50, $1,200. Okay, go ahead and connect the dots. Okay, I'm going to label that one Rocky Cycle Center so I remember that that's for Rockies. Are they renting their bikes at a constant rate? Do we have a straight line? Does it look perfectly straight? So is it a constant rate? In order to be a constant rate, it has to be a perfectly straight line, and this is not a perfectly straight line. It starts to curve. Okay? So then we have to graph the other one. Pebbles Bike Shop. I'm going to change colors. Okay, 5 bikes is $150. 10 bikes is $300. 15 bikes, $450. 20 bikes, $600. 25 bikes, $750. 30 bikes, $900. 35, $1,050. 40, $1,200. 45, $1,350. And 50 is $1,500. Connect the dots. Are they selling their bike or renting their bikes at a constant rate? Yeah, that one was a little easier to graph, right? Because all the dots lined up perfectly. Okay, now what I want you to do is flip to the back side of the page. And there are 4 questions. Okay, I want you to work with the people around you. I don't care if you get up and move. I want you to talk to the people around you. I want you to try to answer those 4 questions. Okay, go ahead and move, talk to people around you, talk to classmates. Try to answer those 4 questions. Everybody's attention up here. Okay, so you can stay sitting where you are because you guys can work together on the next part in a little bit. But I want you to pay attention. Let's have a conversation about these questions. So the first question was, which bike shop should Boulder Bike Tours use? Should they rent bikes from Pebbles or Rockies? What did you guys decide? Abby, what'd you guys say? Why? Okay, so they said Pebbles because it was consistent. Okay, Brayden? Okay, so that group over there said Rockies because the more you rent, the cheaper it is. Okay, so show of hands. Who all said we're going to rent from Pebbles? Raise your hand. And there's not a right or wrong answer here, so it's okay. So the majority of the class said Pebbles. You guys are the only group that said Rockies. Did anybody else say Rockies? Okay, and that's okay. So what we need to think about on this one, we kind of had mixed feelings. You know, a lot of us said Pebbles. What the rest of your groups? This group I know said Pebbles because it was consistent. Did the rest of you have a reason why you chose Pebbles? They said it was consistent too, okay. What was your reason? Because it was a straight line? Okay, so I want you to know that a straight line doesn't always mean it's better, okay? Now, I think we could go either way here. So which bike shop should we use? It kind of depends. Would you agree that it depends? What does it depend on? What's going to make your decision of which bike shop to use? How many bikes you need? right? If I only need to rent 5 bikes, what bike shop should I go with? Absolutely, go with Pebbles. They're way cheaper, right? If I need to rent 50 bikes, what bike shop should I go with? What if I need to rent 37 bikes? What if I need to rent 37 bikes? Who should I go with? Go to both of them. Why doesn't it really matter at 37 bikes? That's when the lines cross, and it doesn't really matter then, okay? So I would say it completely depends on how many bikes you're renting. So it depends on the number of bikes needed. Okay, and that kind of answers our second question also. Explain how you use the information in the graph to make your decision. Some of you made your decision based on the straightness of the line. Some of you made your decision based on it being more expensive or less expensive for more bikes, okay? Was it difficult to compare the prices of the two companies? A little bit, maybe, right? Because one was constant and one wasn't. So why was it difficult? I would probably say one was constant and one wasn't. Which company had a constant rate of change? Which one was constant? Go ahead, Abby. Pebbles. And how could we tell? It was a straight line. Okay, so here's what you guys are going to do next. And this is actually going to be your homework. Okay? Your homework is to finish this page of notes. Okay? So the rest of this problem says, after graduating from college, Luke and Maddie both bought new cars for commuting to work. One afternoon, they had a friendly argument about whose car has better gas mileage. Okay, Maddie's car used 20 gallons to travel 580 miles. Luke's car used 14 gallons to travel 371 miles. For each car, find the unit rate describing the mileage. Okay? Which car got better gas mileage? In other words, which car went more miles per gallon? Right? So I'm going to help you set these up. When we want to find miles per gallon, we're going to write miles over gallons. So you're going to do Maddie's car. You're going to do miles over gallons for Luke's car. You're going to write the rate with the numbers given. You're given Maddie's car and Luke's car. Now, once you have the unit rates, then, everybody pay attention here for a second, then you're going to go to the next part, which says complete the rate table. So fill in the table. Miles in Maddie's car for 0 gallons of gas. Obviously, these first two are going to be 0, right? If you have no gas, you're not traveling anywhere. Once you get the unit rate, you can fill in the next one and then keep going. Then you're going to graph it and you're going to answer the questions. Okay? Now, when you're done with that, here's what you're going to do. On Canvas, under the modules, it's there, okay? On Thursday, March 24th, it says, complete page 6 of your notes packet. Then come back here and upload a picture of the completed page 6. Okay? So you're going to use your Chromebook. You're going to take a picture of page 6. You're going to click on Insert Image, upload the image, and find the picture you want to load, and then submit it. That's your homework. You upload a picture of the finished page 6. Does that make sense? Questions at all? Yes. I'll come and help you in a second. Okay, so you guys go ahead and get started. That's what you have to finish as homework.